Hello and welcome to Maths with El Profilo. In this video we'll be discussing quadratic residues and doing a little bit of this elementary number theory. Okay, so we'll start with the definition and we'll say that we're going to have a be an integer, m be a positive integer where a and m are relatively prime. Okay, then a is said to be a quadratic residue modulo m if the quadratic congruence x squared is equivalent to a mod m is solvable in the set of integers. Otherwise, a is said to be a quadratic non-residue modulo m. Okay? Now, we'll have our first proposition that'll say that if p is an odd prime number and a is an integer where p does not divide a, then this congruence, x squared is equivalent to a mod p, has either no solutions or exactly two incongruent solutions modulo p. We'll look at this in another video. Okay. Additionally, we have a proposition that says if p is an odd prime number, then there are exactly p minus 1 over 2 incongruent quadratic residues modulo p, and exactly p minus 1 over 2 incongruent quadratic non-residues modulo p. So in other words, we will have half of the positive integers less than p will be residues of a quadratic congruence modulo p, and half of them will be non-residues of a quadratic congruence modulo p. Okay, so let's go ahead and work through an example on this second proposition, proposition 4.3. Okay, so let's say that we want to find all incongruent quadratic residues and non-residues modulo 13. Okay, so this is akin to asking if x were an integer, what values of a are possible in the quadratic congruence x squared is equivalent to a mod 13, right? So if x could be any integer, what possible remainders would we have on division by 13? Okay. Well, from proposition 4.3, there are exactly 6, half of the integers less than 13, right? There are exactly 6 incongruent quadratic residues modulo 13 and an equal number of incongruent quadratic non-residues. Okay, so what do we do then? Well, we just need to find the first 6 residues of x squared modulo 13. Well, that would be looking at 1 squared, that's 1 mod 13. 2 squared, that's 4 mod 13. 3 squared is 9 mod 13. 4 squared is 3 mod 13 because 4 squared is 16 and 16 is 3 more than 13. 5 squared is 12 mod 13 because 5 squared is 25 and 25 is 12 more than 13. And 6 squared is 10 mod 13 because 6 squared is 36 and 36 is 10 more than 26, which is a multiple of 13. Right? So our quadratic residues, right, the 6 quadratic residues, the possible remainders I would have when a perfect square is divided by 13 are given by these residues right here, namely, in order, 1, 3, 4, 9, 10, and 12. Right? So a permutation of these, right, where we had 1, 4, 9, 3, 12, 10, but these are our residues, right, and that's half of the digits less than 13. What about our non-residues? Our non-residues would be the other half of the digits, right? So if these are residues, then 2, 5, 6, 7, 8, and 11 are the non-residues, meaning it is impossible to have a remainder of 2 when a perfect square is divided by 13. It's impossible to have a remainder of 5 when a perfect square is divided by 13. And similarly, 6, 7, 8, and 11. The only possible remainders when a perfect square is divided by 13 would be 1, 3, 4, 9, 10, and 12, because these are the 6 quadratic residues modulo 13. Okay. This has been Maths with El Profe Lo. We'll continue in a couple more videos discussing these quadratic residues. As always, please reach out if you have questions.